In this video, we look at how an integrating factor can be used to solve some first-order differential equations. And this work is part of the Unit 4 of the WJEC for the mathematics specification. So, we can use an integrating factor to solve differential equations of the form dy by dx plus p of x times y equals q of x, and we should be able to find both general and particular solutions to such differential equations. Now, with the integrating factor method for solving differential equations, we must have an equation in the form dy by dx plus p of x times y equals f of x. And the integrating factor is defined to be the result of integrating p of x and then raising that to the power e. So the integrating factor I of x is e to the integral of p. If we then multiply the original differential equation through by the integrating factor, then the left-hand side of the resulting equation is in fact the result of using the product rule to differentiate I of x times y. So the left-hand side can be rewritten as d by dx of I of x times y equals I of x times f of x, and then we can integrate each side of the equation to obtain I of x times y is the integral of I of x times f of x. So we'll have a look at this in a couple of examples. In the first example, we have a curve which satisfies the differential equation x plus y dy by dx minus xy equals 4e to the 3x for values of x which are greater than minus 1. And we have to find the equation of the curve given that it passes through the point 0, minus 7. Now at the moment, this differential equation we've got is not in the form dy by dx plus p of x times y equals f of x. However, if we divide the equation through by x plus y, we obtain dy by dx plus minus x over x plus y times y equals 4 over x plus 1 times e to the 3x. And now we are in precisely the required form for using an integrating factor. The equation we've got here is dy by dx plus p of x times y, where p of x is minus x over x plus y, equals f of x, where f of x is 4 over x plus 1 times e to the 3x. So the integrating factor is going to be given by the e to the integral of minus x over x plus 1. So we've got a little bit of work to do to find out what this integrating factor is. Now, using polynomial division, we've got x over x plus 1 is the same thing as x plus 1 over x plus 1 take away 1 over x plus 1. So that's the same thing as 1 minus 1 over x plus 1. So, minus x over x plus 1 is the same thing as minus 1 plus 1 over x plus 1. Which means that the integrating factor is e to the integral of minus 1 plus 1 over x plus 1 Minus 1 integrates to x. 1 over x plus 1 integrates to the natural logarithm of x plus 1. So we've got e to the minus x plus the natural logarithm of x plus 1. When we're dealing with an integrating factor, we do not need to worry too much about the constant of integration. Doesn't matter at this stage. Now e to the minus x plus ln of x plus 1 is the same thing as e to the minus x times by e to the natural logarithm of x plus 1. So that is the same thing as e to the minus x times by x plus 1. So our integrating factor is x plus 1 times by e to the minus x. So we now need to multiply the whole of our differential equation through by the integrating factor. So our differential equation was dy by dx plus minus x over x plus 1 times y equals 4 over x plus 1 e to the 3x, and we're going to multiply that through by x plus 1 e to the minus x. So we obtain x plus 1 e to the minus x times dy by dx plus x plus 1 e to the minus x times by minus x over x plus 1 y equals x plus 1 e to the minus x times by 4 over x plus 1 e to the 3x. Now, simplifying this equation, we have x plus 1 e to the minus x dy by dx minus x e to the minus x times by y equals 4e to the 2x. Now, the whole point of introducing the integrating factor is that the left-hand side now is a perfect derivative of the integrating factor times by y. So the left-hand side can be written as d by dx of x plus y e to the minus x times by y. And that is equal to 4e to the 2x. So we can now integrate each side with respect to x to obtain x plus y e to the minus x times y equals the integral of 4e to the 2x. In other words, x plus y e to the minus x times y is equal to 2e to the 2x plus c. Now we're told that the curve passes through the point x equals 0, y equals minus 7. So if we substitute in x equals 0, y equals minus 7 to our equation, the left-hand side becomes minus 7 equals 2 plus c. So we've got c must be minus 9. So the solution of the equation is x plus 1 e to the minus x times y equals 2e to the 2x, take away 9. And it's fairly easy to rearrange that to make the solution y equals. So if we divide through by x plus 1 e to the minus x, we obtain y equals 2e to the 2x over x plus 1 e to the minus x minus 9 divided by x plus 1 e to the minus x. And that is the same thing as 2e to the 3x over x plus 1, take away 9e to the x over x plus 1. Now let's move on to a second example. So for the first part of the question, it says if y equals 1 over u, then write an expression for dy by dx in terms of u and du by dx. We'll start off by doing that. So if y is 1 over u, then the chain rule is going to tell me that dy by dx is dy by du times by du by dx. But dy by du is simply minus 1 over u squared, because y is 1 over u. So I've got dy by dx is minus 1 over u squared times by du by dx. Now for part B then, we've got to show that the substitution y equals 1 over u transforms the equation x dy by dx plus 3y equals x squared y squared into x du by dx minus 3u equals minus x squared. So we know that y is 1 over u, so x dy by dx is going to become x times minus 1 over u squared du by dx. 3y is going to become 3 over u, and x squared y squared is going to become x squared times 1 over u squared, so that's going to be x squared over u squared. If we now multiply through by u squared, we've got minus x du by dx plus 3u equals x squared. And then multiplying up by minus 1 takes me to x du by dx minus 3u equals minus x squared, as required. Now the next part of the question says, hence find the general solution of equation 1. They've just made me find equation to show that equation 1 is equivalent to equation 2. So what we're going to do is we're going to solve equation 2 first of all, and then deduce the solution of equation 1. So we've got x du by dx minus 3u is equal to minus x squared. We can't use an integrating factor on this equation as it stands, because to use an integrating factor we must have the equation in the form dy by dx plus a function of x times by y equals another function of x. So we need to get rid of that x in front of the du by dx, so we're going to divide through by x first. So we've got du by dx minus 3 over x times u equals minus x. So this is the same as du by dx plus minus 3 over x times u equals minus x. So we've now got the equation in exactly the form we want. We've got du by dx plus p of x times u equals f of x, where p of x is minus 3 over x and f of x is minus x. This equation can be solved using an integrating factor, and the integrating factor is going to be e to the integral of minus 3 over x. In other words, the integrating factor is e to the minus 3 times the logarithm of x, which is the same thing as e to the logarithm of x to the minus 3, which is just x to the minus 3. So we are going to multiply the whole of our equation through by x to the minus 3, In other words, we're multiplying through by 1 over x cubed. So we've got 1 over x cubed du by dx minus 3 over x to the 4 times u equals minus 1 over x squared. Now, when we've gone through the integrating factor method, the left-hand side of our equation should now be, and indeed is, simply the derivative of the integrating factor times by, in this case, u. So the left-hand side is the derivative of 1 over x cubed times u. So I've got the derivative of 1 over x cubed u is equal to minus 1 over x squared. So I can integrate each side with respect to x and obtain 1 over x cubed u is equal to the integral of minus 1 over x squared, which is just 1 over x plus c. So multiplying up by x cubed, I've got u equals x squared plus c times x cubed, where c is a constant. And finally, we know that y is 1 over u. So we've got y equals 1 over x squared plus c times x cubed. And that is my general solution of the original differential equation.